Thank you everybody for attending this live seminar. We will talk about a recently released product of Dispendix, the G.Station. First part will be done by me. I will give you a presentation about the product. And after that, Holger from Dispendix will give you a live demo of the device so you can see it yourself. So who are we today? I'm now Putman. I'm a technical sales specialist at Dispendix, and as I said before, I'll be doing the first part of the presentation that will be followed up by Holger Armbruster. He's Global Product Manager at Dispendix. So he has a lot of in-depth knowledge about the product of Dispendix, the G.Station, and Nick Imming will lead the seminar and will make sure all the questions will be answered. He's a marketing specialist at MBS Scientific. So for today, in short, what we will be talking about, I'll tell shortly about MBS Scientific as an organization. Then Holger will tell something about Dispendix. Then we will go to the product, the G.Station. We will talk about the features, applications, and all the benefits. And then it will be followed up with a live demo. So before we start, this webinar will take about 50 minutes with 10 minutes which are reserved for additional questions. The webinar will be recorded so it can be sent afterwards if you're interested to seeing the webinar again. Your microphone and camera are turned off automatically, so if you have any questions, please ask them in the chat. Nick will make sure the questions will arrive with me and Holger and make sure they are answered. And of course, if you rather have that we answer your question personally by email or on phone, send us an email or you can always call us. So let me start with telling you a little bit about us, about MBS Scientific. We are a distributor of laboratory products in different segments in the sector. So we do products for sample collection, handling, managing and storage, sample and liquid preparation, liquid handling, cell culture and medium preparation, and laboratory automation. So we have a very broad field of products, and always striving to help our clients the best in those segments. We are internationally located, so again we deliver a wide range of products in more than 10 countries, in organizations like laboratories, hospitals, universities, and biobanks. We already have 20 years of experience in the life science industry. Today we sit with our partner Dispendix, and we are a supplier within Europe of their products. So we always strive to go for our 4 core values, which are innovation. We always stand for innovative solutions and keep up with the latest trends. We like to be creative, find creative solutions, and think with our customers on a personal level as well. And we strive for quality. We not only aim to deliver products of the highest quality, but we also value a quality of life. And last but not least, we always aim to be sustainable. We aim to do our part for a more sustainable environment, also by choosing our partners sustainable. And with those 4 values, we always aim to offer high quality products and high quality service for our customers. So I'll give the word to Holger shortly to tell a little bit about Dispendix.
Thank you so much, Nout, and also thank you for the kind introduction. So my name is Holger and I'm the product manager at Dispendix. So Dispendix is a German company. We're based in the southern part of Germany, in Stuttgart to be precise. And we're doing non-contact liquid handling solutions. from the nano to the microliter range. So we're going to the very low range, a couple of nanoliters, up to 1 milliliter of transfer volume. So we can provide solutions for complete workflows. We're focused mainly on the automation and microfluidics for genomics and drug discovery. So these are our core markets, our core segments. But obviously, our products can be used universally for liquid handling. So if you have an application which fits not precisely into these two buckets, don't be shy to contact us. We'll see how it fits. Yeah. We are around 70 employees right now, based here in the headquarters in Stuttgart, but then also in the field, of course. So we have a strong field presence in Europe, but also in the US to support directly, consult, and help you if you need support. And we also have a great engineering team in Indonesia. So we're also being very international and connected around the world. Dispendix was founded in 2016 from the Fraunhofer IPA Research Institute here in Stuttgart, Germany. And then we joined the BICO group in 2018. We are steadily spreading our footprint in the scientific landscape. So right now we are present in around 300 laboratories. So that's what you would call the installed base. And yeah, these labs are spread almost across the whole globe. Just last week, I did an installation in Saudi Arabia, for example, which was fun. So yeah, so we come to our customers if they need us. Okay.
Yeah, thank you, Holger. Sounds good. So we continue with well, telling something about how Dispendix fits in the portfolio of MBS Scientific. As I said before, we offer a broad range of products, and where Dispendix comes in is mainly the automation part within liquid handling and sample preparation. So Dispendix has liquid handlers and offers automated workflows for example, NGS library preparation, which makes it a perfect fit for our segments, liquid handling and sample preparation. So let's dive in the new product, the G.Station. The G.Station is a device developed to automate NGS library preparation. It's the ultimate solution for automated NGS library construction and enables users to easily execute an entire NGS workflow. It uses state-of-the-art liquid handling technology, and it also works with Dispendix cloud software. We will tell more in detail about it later on in the presentation. Here on the right, you can see the basic setup of the G.Station. You see the liquid handler, the L-drop, which is the bigger device, and the I.dot in the left back of the picture. And on the right, you can see the connecting part, which is the robotic arm. And in this way, we can connect the full workflow and automate it completely. So here are all the individual parts which can be integrated in the G.Station. So you just saw on the tabletop, you saw the I.dot, which is a nano volume dispenser and is able to dispense volumes of 2.5 nanoliter to 1 microliter. And that can be connected to the L-drop, which is able to dispense 1 microliter to 1000 microliter. And so you can have an automated workflow with a dispense range from 2.5 nanoliters to 1000 microliters. Moreover, a thermocycler can be connected and a G-Pure for automatic magnetic bead cleanups. So all in all, the whole workflow can be completely automated with those integrated devices. And additional parts can be added, like a cooling module or a shaking module. Those modules can heat as well, so you can create the perfect environment for your samples within your preparation workflow. So this is the KX2 robotic arm, which is the connecting part of the G.Station. It brings all the individual parts together. It's a robotic arm which you install once on your tabletop, and then you can just let it flow. You don't have to do anything with it again. You can just start your protocol, and it every day it will execute your protocol as you like. So that's really really convenient. So the G.Station, it makes sure your DNA and RNA gets in, and high quality libraries will come out as output. So it's for next gen sequencing. I already talked a little bit about it. The IDOT, which is able to dispense from 2.5 nanoliters to 1 microliter. It's a non-contact dispenser, which means you don't need any pipette tips. And you can add enzymes, ligation buffers, PCR master mixes, and beads. Moreover, it ensures low dead volume of 1 microliter. Again, it has tip-free technology, which on the long term, it will save a lot of costs on pipette tips, and it's really sustainable as well. And it even has droplet detection, which means it ensures the accuracy of your dispensing rate at really low volumes. Also the L-Drop, which is the liquid handling station. It's a tip-based liquid transferring device, and it operates by a cloud software completely. So it has a wireless connection to your computer, which makes it very flexible. It makes you can upload your protocol from anywhere, such that your location is mobile and flexible, which is quite new in the market. It has pressure and flow sensors to update you on the volume that is dispensed and for external checks. And it can hold up to 20 racks and plates on the deck. So you can, for preparation, you can prepare multiple rounds, which makes it very time efficient as well. It has 8 pipette tips, as you can see in the picture, and all the pipette tips are able to move individually. So you're not limited to a distance. It's quite flexible in terms of mobility of the individual pipette tips. So a G-Pure cleanup device can be added as well. It loads and removes ethanol and adds resuspension buffer as part of the tip-free and bead-based cleanup process. So this can be integrated in your automatic protocol as well. And other accessories can be added as well, like the shaking module, the cooling module, or a heating module. So all in all, it makes it a very complete package by which you can automate your protocol. Here you can see a nice overview of the benchtop. On the left, you see the L-Drop, then you see the robotic arm, then you see the G-Pure, and then the IDOT. All you need is one benchtop, and you can perform high-end protocols automatically. You can enhance your reproducibility and increase your efficiency, and you can save a lot on consumables. Because, for example, for the IDOT, you don't need any pipette tips. So what are the benefits of the G.Station? Here you can see 6 benefits. The first one is to conserve reagents. You can miniaturize your process and dispense reagents with a 1 microliter dead volume, and you can run more samples for the same reagent costs. You can practice your sustainability because it's a non-contact dispensing and bead-based cleanups, and you can allow to use a fraction of the pipette tips required for traditional NGS automation. So in the long term, it's very sustainable and even a cost saving as well. It's cloud controlled. You can have 24/7 access to the cloud dashboards, and from your dashboard on your laptop, you can edit, run, and monitor protocols remotely. And you can share your protocols with colleagues, by which you can so you can share protocols, and other colleagues might save time because they don't have to make the protocol themselves. It's all in the same database. And again, you can sit anywhere as long as your laptop is on and the devices are on. You can run your protocols from anywhere. It's a very quick setup. There is a fixed configuration. So as I said before, it has to be installed once and then you don't have to touch it anymore. You can just run standardized protocols again and again. This ensures high quality libraries within a few days after installation. So that's really good. So the results are very trustworthy because you can dispense with insights into the actual volume dispensed. As I told before, the iDot has a controlling mechanism. It's a laser technology which counts all the droplets such that it can ensure trustworthy results even at very low volumes, for example, in a nanoliter range. And the working that can be monitored via the included high-resolution cameras. And the library tools, you can work with the tools that are available to you anytime. The protocols are standardized and tested. You can choose from a standard set of liquid classes, or you can create liquid classes together with Dispendix. So it can be very personalized and customized. And there is a big library of labware available. And also for the labware, this can be very personalized and customized. Together with Dispendix, you can create your own library of the labware you are using. So to dive a little bit into the software, it has an integrated cloud software. Here it brings all the elements together. There's just one software you can use to run the whole setup, which makes it quite convenient. It's very easy in use. You don't need a lot of education on it. I think it's a very straightforward software. It's really user-friendly, which makes it really nice to work with. And also for newer people, if there are new people on the workflow, they can learn it real quick, such that they can execute the tasks very quickly as well. It keeps track on volumes dispensed, so you get feedback. It offers full access to the libraries, as I told you before. If you're using your own labware or your own fluids, together with Dispendix, you can create a library which is personalized to make it a really good fit for your own workflow. You can write and save your own protocols. So, for example, if your protocols are similar over days or weeks, you don't have to make new protocols every time. It's just saved and you can run it in the morning and it's done at the end of the day. And you can even test new protocols with digital test runs, so you can see how long your created protocol would take in practice. So it's kind of a simulation run. So you can test your new protocols based on time and efficiency. So what are some applications the G.Station can be used for example, for DNA sequencing, RNA sequencing, and targeted sequencing. And the G.Station is, for example, compatible with the Illumina DNA prep kit, the enzymatic fragmentation kit from Twist, the Sequel kit, and the kits from Roche for DNA sequencing. Also within RNA sequencing, it's compatible with Illumina RNA preparation kits, the Plexwell rapid single cell kits, the Cara BioSmart sequencing kits, and the cDNA synthesis. And for targeted sequencing, you can, for example, use Twist XM 2.0. So some of the core workflow steps, the whole protocol is really good for NGS library preparation, and this can be broken down into 4 workflow steps. 1 is the reagent dispensing, 2 is the bead-based cleanups, 3 is the sample transfers, and 4 temperature control with the accessories like incubations and amplification. So thank you. I hope I gave you a bit of a good image of the G.Station, such that Holger can follow up now with a live demonstration of the G.Station.
Great. Thank you so much, Naud. So that was a good summary of the G.Station, of its capabilities. And now we want to see a bit in live, right? So I will start with showing you around the system. So I'm here at our demo system in Stuttgart, our development system. So we're going to show you around, and then we're going to have a look at the software. So I'm going to show you how the software looks like, and we can maybe also set up like a small protocol, and then we can run a protocol to give you an idea how the system looks in action. So I have mounted a camera on top of my laptop, and so I'll try my best to give you like a good idea of the system. Okay. So what you see here in the front of the system, this is the L-drop liquid handler, right? So this is the higher volume device for handling higher volumes of liquid, and we mainly use this as an entry point to the system. So you would put in your reagents, your tips, your plates. So anything you need to like bring into your workflow, you would put on the stack. It has quite some space, yet it's not oversized, so it's a nice fit. And then all the other devices are located here at the back of the instrument. So we do see here the robotic arm. So that's the KX2 arm that Naud already mentioned. So this arm is basically transporting all the labware between the devices, right? So it would bring blades from the L-drop deck into the IDOT low volume liquid handler. So that's here what you see here. And we would use the IDOT, the low volume dispenser, for all following steps of dispensing reagents, enzymes, primers, everything where you can like downscale and have like low volumes. We would do this with the IDOT. And then next to the IDOT, we do have the CWash. Just going to move around a little bit. So that is the magnetic bead cleanup device. So after you've done your PCR reactions, your amplification reactions, you would just put in your magnetic bead plates, your PCR plates into the CWash. It would do the complete PCR and magnetic bead cleanup step, and then you would go back to the L-drop and do the final elution step. So that's like a short example of how a workflow could look like with the G.Station. So really, if you compare the G.Station against like other standard NGS library prep systems, those standard systems typically consist of just a liquid handler, right, which can go from like, low microliter volumes up to like 1000 microliters mainly. And then you've got a PCR cycler, heating, cooling, shaking device, but that's it. And in the G.Station, what you do have on top is the IDOT, so the nanoliter dispenser, and the G.Pure. And by integrating these devices, we can significantly downscale reaction volumes, right? So we can decrease reagent volumes by a factor of up to 10. for example. We can save quite some tips. So that starts with the dispensing steps, where you would only need tips basically to bring your reagents and samples from your original tubes into IDOT source plates, and then we do the following steps with the IDOT. And then also the GPO, the magnetic bead cleanup device, adds like a huge value from that perspective, because these magnetic bead cleanup steps do take really quite some tips and time. So we offer really a bunch of advantages over these traditional liquid handling systems. So please keep that in mind. So this is really like a additional value we're adding to NGS library prep workflows with the G.Station. Okay, so with that being said, I would first, as said, show you the software, and then run a protocol on the device. Here we go. So the G.Station software, the Dispendix cloud software, is, as the name tells, a cloud software. And the cool feature here is that you can access it from everywhere, right? So wherever I am in the world, may it be on my way to work, may it be in the home office, I can easily access. And it also means you can easily share protocols, right, in your bubble, right? Because every like work cell is highly protected, so nobody else can come in. But whomever you grant access can come in, and they or you can modify protocols, write protocols, and share these in your user group. So let me sign in. So now I'm opening up the main screen, and it's really a very visual and graphical software. So if you are here at this this home screen or this overview, you would see in the center your protocol folder structure. And this is an R&D system, so there are a bunch of protocols and folders in here, but basically it's a folder structure where you could create and save your protocols. So you would see exactly like who set these up and when they were run, for example, right? So you can easily like follow up. But there also is another like run report in the software, of course. So that's the home screen, and then we've got the virtual lab. So this is like the overview, right? So in this section, we do see all the devices which are connected to the software, and this is the L-drop, the IDOT, the shakers, the heat, the coolers, and so on. And you can manually control these. So you could say home instrument. You can use it for error recovery, for example. So it's quite easy to also manually control the devices. And then we've got the library. So we've got like a really huge library of labware. In the meantime, we can also create labware for you if you've got something special. We've got tips, liquid classes, and liquid. So it's like the standard, I would say, that you do have in automated systems and that you do need. And then the other thing that I wanted to show you is the run overview. So this is like the run log. So all the protocols which were run on the system are saved here, right? And the cool thing is that this is not only like a cryptical report, but if you click onto like one of these protocols, you would exactly see like all the steps that have been performed here. You would see how long the protocol took, if there were any like error messages, and you can really easily like follow up how the transfer steps have been done, for example, and what exactly has been happening. So it's also like a good way of tracking what has been done on the G.Station and to ensure quality control also. Okay. Now, I did set up a demo protocol, and that's the one I'm gonna run also in a few minutes. But for now, I would want to show you just how to quickly create a protocol, and don't be don't think you need to do this all on your own, because if you decide to go for a G.Station, we would create at least one of your protocols, so whether we have it already, right, or we would create it for you and also reagent test it. So we have like a highly skilled team here which will run your protocols, test them, so that when we come on site, it doesn't take much more fine-tuning and development. So that being said, what I'm going to show right now is like the principle of how to set up a protocol. It's a very visual, workflow-based approach. So if you can think about it like going to your lab, right? So if you go to your lab, what you would first do is you would pick your reagents, you would pick your consumables, and that's exactly what you would do now. So we can go to the library and can say, for now, for example, we want to have a 96-well plate. All right, so we could use any PCR plate. We click it, and it might be empty, it might be filled. If it is filled, you would just, if there are, for example, samples already in it, you would just like mark the wells that you need and then add a liquid. For now, we would leave this empty. Add to protocol, and then we would maybe want to just transfer reagents from a reservoir. Let's just take that one. We add a liquid, so let's just add water here, and we'll give it, change the units here, of course, also. We could just give it like 100 milliliters, for example. Okay, and now what you would do next, so think about like now you've got all your consumables and lab where you need, and now you would start creating your workflow. So if we just want to fill a plate, right, we would go to the liquid handling section here, and there are like a bunch of commands, right? So there's like a serial dilution wizard, there's a mixing step, a normalization step. But if we just want to keep it very simple, we would go for transfer, drag it in here. Then we go back to our lab where we say we want to go from our reservoir into the destination plate. And if we click in here, we would now set this transfer. So we would select like the source section. So let's say select this, and then we select like in which wells we want to transfer. So we could, mark the complete plate or just like sections of it, single wells, whatever you want to do, or the complete one. You could also, of course, load all this data in via a work list, via CSV file, so that's completely compatible. And then there are different options like how to fill the plate, in which order, and other things. If we set a transfer volume of, let's say, just like 100 microliters, we would then see below exactly the transfer steps, right? So that's now not so exciting because it's like an easy transfer, but if you've got like a complicated pattern, you can nicely like follow up what has been happening and what is happening. Okay, now we save this, and as you have seen, we haven't now gone into very much detail, right? So we haven't defined like which tips we need or like how the head needs to move and with which speed. And that's the cool thing about the software, because it really translates your scientific intent, so your protocol, into automation, right? Because now what the system does, if we hit lab sync, it would translate it to our system. So we can just call this demo, for example, and then we would select which devices we want to use and some other options here. Now we're creating the instrument settings, so that means like how we actually want to do the transfer. Now this protocol here is like, it's an easier one, so the list here is not very long, but typically like the list here in the instrument settings is much longer, because you would have like all these single movement steps and so on. And now we would theoretically already be good to start. We could change this of course, so we could like move around stuff, and if we do something wrong, the software would tell us like it's not a good idea to put it here, because here it would saying placing the highlighted labware side by side will likely result in a crash, so better put it here so you do get warnings if you're doing anything wrong. And then of course you can also change your settings, right? So the settings which are chosen here automatically are very good. So I've worked with a couple of liquid handling systems, and really like the software has like the lowest need for manual input from what I've seen in my career. So the manual settings or the automatic settings here are very good, but of course you can manipulate them. So you can say how fast you want to dispense or aspirate. You can define if you want to do a tip wedding, if you want to have an air gap, and so on and so on. And of course, let's save this. You could, before you start running the protocol, you could do a virtual run. So you could have the software check it for feasibility. Right, so now it's basically doing a simulation. It would also give you a timing. And now this is a fairly long transfer, and that's because we are exchanging tips. So I didn't select to use the same tips for the complete transfer. Obviously, that would be much shorter if we just like use the same tips for all transfer steps. But now here we could run a simulation, so we could see exactly now what's happening. So it's loading tips, it's expiring, it's dispensing, and so on. Again, here, with that easy example, it's not that exciting, but if you're having more complicated patterns, it's really straightforward and a nice feature. Okay. So that was like a very quick intro into the software. Obviously, if you are interested in having like, or if you have questions or want to see it like while doing your application, we're more than happy to support and to explain you like how it will benefit your workflow. So what I want to do now is run this demo protocol that I did create. So this is like a like also like not a huge protocol, but I think you will see some movements and hopefully get an idea of like how the system functions. So what we do here in this protocol, we've got a tube rack. We would basically transfer from 8 wells here. So we've got 8 tubes, Eppendorf tubes loaded, and we would transfer this reagent or these reagents into a half of a 19.6 well plate. That's here. Then we would put the plate on a shaker, shake it quickly, and then afterwards we would add it to a magnet plate. So maybe that could be like a magnetic bead, the beginning of a magnetic bead cleanup, right? So maybe adding the magnetic beads, shake it with your samples, and then put it on the plate. That's what it could be. It's it's just designed to give you an idea of like how the system works. Good. So now I have already done the lab sync here, so the translation into automation. So I go into the instrument settings, I go for protocol, and now this is, as I said, the translated protocol, so the translation to the automation system. So now here on that side, you would see like all the single commands, right? So the deck setup, the transfer, then a parking step, unlocking the shaker, locking the shaker, shaking, and so on. But these are all steps, again, that you did not need to think about, right? So you just say shake it, and then like the device does all the thinking for you. And that's a cool thing, I would say. Okay. So I would now, again, take the camera. And I just want to make sure that I do see what I'm doing. So we've got all the tips here, and then we've got our tubes here. We've got the magnet plate here, and we've got the PCR plate over here, and then like on the right side, we've got the shaker, the plate shaker, and also a cooling device for reagents, which we are not using here. So now, if I hit run and accept this, so the system would now initialize. Right. And the good thing is it wouldn't start like straight away, right? But it would ask you before, like, have you put all your reagents in the right position? So you do see the deck overview here. You can double check, are these all on the right locations? And if you click into these, you would also see exactly like what volume you do require. So if you confirm and say continue, now I would stop sharing. It's easier for me to show. I think I want to pause it real quick. I need to get this camera setting here in it. Okay, so now we can continue. So we loaded like the first four from the first four tubes, and now we are loading from the second four tubes. Now we've got 8 tubes loaded, and we're moving over to the target plate. And this is now a multi-dispense, so instead of like going forward and backwards between the source and the plate, we're just like loading once and then dispensing in one go, like you would maybe do with an electronic multi-pipette. It's good now. And in that case, I programmed the protocol in a way so that it puts back the tips into the tip box. But of course, there's also a trash where you can place them. It's just a little bit more convenient for them also. Okay. Now the pipetting head is moving backwards, and now in the next step we will move the plate, so the PCR plate, to the shaker. Right, so now the arm is coming, it's grabbing the plate, and it's moving the plate over to the shaker. The shaker is locking. So there's a active locking mechanism to make sure that your plates are like sitting and staying on the shaker and not flying away while you're shaking. You could, of course, so there are different ways to mix, by the way. So you can do mixing by shaking, but you could also mix your reagents with the pipette tip. So you can go up and down with the pipette tip, depending on what is best for your protocols. Now the shaker's unlocking. And the arm will now grab the plate. It's now taking the plate and just putting it on a magnet plate in that case. And yeah, that's it. I mean, that was really just like an example to give you a little bit of a a look and a feel of the system. If we look back now into the software, you would see that the whole process did run smoothly. So yeah, we did have no error messages. And now we can see, if we now go back to the run reports, we would see that that one was the run we just did, that started at like 1 p.m. and 46 minutes. We've got the name of the protocol. We see who did run the protocol. And if we open it up, we would see that all steps were performed correctly. Okay. Yeah, as said, that was an example. The idea was to give you like an idea of the system. And of course, we are more than happy to dive deeper into the system and into the workflows together with you, depending on your requirements and needs. Good. And I think with that, we can open it up for questions, right?
Yes, thanks a lot, Holger, for this very nice introduction of the G.Station. To me, it was very clear. I hope to the other people watching the seminar as well. I hope you've gained a good image of the G.Station and what it might do for your lab. So we want to thank you for your attention. If you want to contact us, please reach out to one of those contact details according to your country and your location. And with that, I think we can open the questions from the people watching the seminar.
We got a question. Someone asked, how can you make sure to not contaminate the bottom of your IDOT source plate?
Yeah, this is actually an advantage of the system. So there are a couple of things. So contamination, that can mean a couple of things. So obviously, like the bottom of the source plate, like the well opening, has a certain distance from the surface, right? So if you put the source plate on the table, it wouldn't touch anything, right? So there's a small gap. That's the one thing. And then what we do here is non-contact dispensing, right? So we are dispensing like tiny little droplets from the pore at the bottom of the well, and the liquids are being dispensed so precisely that you're only dispensing these liquids, and there's no remaining liquid at the bottom of the well, right? So no droplets there, and we reach that by very precisely defining the pressure applied to each liquid, right? So for each liquid, we have a very precisely defined calibration curve, which makes sure that like these liquids are being handled correctly. So for example, for highly viscous liquids, you would apply a higher pressure to dispense the same liquid as compared to, for example, methanol, right? So we can cover like a good range there. So the answer is we make sure that all the droplets are being really released and dispensed very correctly. And we also have a verification tool for this. So every droplet that is being dispensed is counted, right? So below each of the wells, there is a light barrier. So if there's anything off with the dispensing and your droplets are not flying through, we would see this, because then like the light barrier would not be triggered and we would get like an error message which tells us there's like something wrong. So this was about the IDOT. And then we've got another one about the GPure, right? So the GPure, that's the magnetic bead cleanup device. Again, this is also an important question. So the GPure is applying centrifugal forces, right, to get rid of the liquid. So instead of using tips, it spins the blade. And the trick here, again, is to really precisely define the acceleration and the speed of the centrifuge. So that is how we make sure that there's no no carryover. And of course, we tested this like very rigorously. So we did single cell sequencing experiments where we checked mouse versus human DNA. So we had like mouse and human samples on the plate, and there's also like a nice publication regarding this, which we can share. And you would see that you've got virtually like no cross contamination between mouse and human samples. And then of course, there's an active waste pump which pumps like out all the liquid from the GPU immediately. And we do have a cleaning solution, right? So the daily clean solution, which we recommend to use like after each use, or at least a daily of the GPU, to make sure that you're getting rid of everything that is like that may be left inside of the device.
All right, let's hope that answered your question. If there are any more questions, feel free to reach out to us to any of these contact details. And yeah, we hope you have a nice afternoon.
Thank you so much.
Thank you.
Have a good time. Bye-bye.